Hi friends, in this episode we'll see about chilled water and chilled brine, the definition, application of chilled water and chilled brine and how it works. Chilled water. Normally cooling water is used in heat exchangers, coolers and condensers as cooling media. After the chemical treatment and proper cooling in open type cooling tower system or closed circuit cooling system. But cooling water temperature will be 4 to 5 degrees centigrade above the wet bulb temperature only. What is wet bulb temperature? The wet bulb temperature is the lowest temperature that we can reach or that can be reached under current ambient conditions by the evaporation of water only. So that is the lowest temperature we can attain by evaporation. Chilled water is cooling water below the wet bulb temperature in freon compressor that will range around 7 to 12 degrees centigrade. And chilled water is normally used in liquid nitrogen plant and also used in tall buildings and big buildings as alternative to air conditioning system for cooling the buildings. Wet bulb temperature cannot be reached by means of cooling tower. So we can get the cooling water 5 to 5 degrees centigrade above the wet bulb temperature only. The chilled water temperature will be well below the wet bulb temperature and it will be placed in liquid nitrogen plant to cool the air to remove moisture effectively before unwetting in air purifier unit. Chilled brine is chilled water mixed with glycol to produce a freezing point anti-freezing agent that will reduce the freezing point up to minus 60 degrees centigrade so as to get the chilled brine temperature less than 0 degrees centigrade so the water will not get frozen. Chilled brine is also used as sub-zero temperature cold storage bullets, heat exchangers and chillers. Normally it is used in ethylene oxide storage. Properties of ethylene oxide. It is a colorless gas. Melting point is 111.3 degrees centigrade. Boiling point is 10.7 degrees centigrade. Lower explosive limit is 3%. Upper explosive limit is 100%. Highly dangerous and toxic thermal and explosive gas. Its flash point is only 17.8 degrees centigrade only. So it is highly volatile and should be kept very safely. Fire and explosion hazard when exposed to heat or flame is high. So it is provided with nitrogen blanketing and preferably kept in the storage tank refrigerated with chilled brine circulation. So for this usage only chilled brine is used for UO bullet storage and also the storage will be having explosion proof walls. Do not forget to subscribe and share it with your friends. Put your likes and comment in the comment box. We'll see how the chilled brine works in the next slide. Glycol-based coolants are either composed of ethylene glycol or propane glycol. But these two variants have similar physical properties. They should never be mixed. You cannot mix either ethylene glycol or propane glycol. The major advantages of this glycol coolant confers are an improved resistance to corrosion as well as anti-freeze properties. It is anti-corrosive and also anti-freeze properties. It can be mixed with raw water or DM water and can be used as coolant. Using a glycol water mix as a chiller coolant has various benefits over the use of normal water as a chiller fluid. The advantages are due to its unique physical properties which include a lower freezing point than the water. Water free of impurities will freeze, the DM water will freeze at 32 degrees Fahrenheit, which is much higher compared to the pure ethylene glycol which changes to its solid state at 8.9 degrees Fahrenheit. When a glycol water mixture is altered or mixed, the freezing point of the coolant also changes. Cite an example, that is, if 10% ethylene glycol, it will freeze at 25.9 degrees Fahrenheit, while 60% glycol solution will freeze at minus 60 degrees Fahrenheit. That is minus 52.77 degree centigrade only. That is 60% glycol and 40% water. Two types of glycol: monoethylene glycol (MBG C2H6O2) and monopropane glycol MPG C3H8O2. Both can be used, but both cannot be mixed together. MEG or MPG mixed with raw water with RDM water based on the requirement is known as coolant. It is used as jacket cooling in boil-off compressor gases in LNG plants or LPG plants, ethylene storage. Also used as a heating media in LNG regasification plant. That is MEG mixed with DM water is normally used in LNG regasification plant. DM water and MEG can be mixed in the ratio 60:40. Water 60% and 40% MEG or 50:50. With the draw water also can be used. Corrosion and purity is not required. You can use normal water also. MEG and MPG is either 60:40 same, and 50% we can use it for as a chilled brine or as a coolant. In chilled brine also it can be used to get a freezing point lesser than 0 and anti-corrosive property also used. This is a schematic diagram of chiller unit or chilled water compressor in any industry. Now R134A is used in many places. It is tetrafluoroethane CF3CH2F in Gulf countries and in some places in India also. It will be obsolete in 5 more years. In 2025, we have to go for R600 isobutane or for R290 propane. Already it is in use as a global warming potential is very less compared to R135A, which is having GWP 1430 in it. It is already banned or phased out. So in use in some many Europe countries, 600 DA for refrigeration and R290 for chillers and air conditioning unit used. But R134 is used currently in India and also in Gulf countries. Compressors use either reciprocating or screw type in chiller unit normally. Compressor is mixed with oil. It can be the PAG oil, polyalkylene glycol, or PAG based on the viscosity 46 or PAG 100 or 150 along with the refrigerant. Mineral oil like or alkali benzene oil also can be used, or PA oil, polyalpoloolefin oil also can be used. If R600 or 290 is used, we can go for POE, polyester oil or mineral oil can be used. So in future, after 3-4 years, all the industry will go for R600A or for R290 for the chiller compressor. Now we can see the operation of chiller compressor. Either it is a screw compressor or a separating compressor. Nowadays it is used, R134 is used in a compressor. Compressor will compress the gas. The compressed gas will go to condenser where cooling water is emitted to condense the refrigerant or freon or R134A. The condensed liquid will come here. It will get expanded, whereas the temperature will reduce and it will become gas almost, and little liquid also will be there. It will get evaporated and reduce or transfer the cooling with the chilled water. Chilled water will come inside and go chilled out and go out. It will be used in nitrogen plant or wherever it will be. If chilled brine is admitted, then chilled brine will go for the downstream usage. Normally, economizer is also used. Here, before the expansion wall on line is branched, when economizer will be there. should be having temperature control valve that will effectively remove the cold energy so that that will be either recirculated back to the evaporator, or one portion after usage will go to the compressor. In the economizer, the freon will be used in both cell and tube, both sides. One will be getting heated up, another will lose, other will get the cooling. So economizer is very effective. No need for any other foreign media. Only the refrigerant is used that from evaporator that will go and get the heat, whereas they or give the heat, and the liquid freon will get further cooling. So the economizer will work effectively in the chilled water or chilled brine compressor, and this is a in future, R600A or R290 can be used. For large scale, R290 will be used propane. For small capacity, you can go for R600E. So this is a normal schematic diagram of chiller unit used in industries for chilled water or chilled brine production. Hope you might have understand the chilled water, chilled brine compressor working principle, usage in the previous slides. Do not forget to subscribe, share it with your friends and colleagues. Put your likes and comments in the comment box. See you in the next episode. Thank you very much.